In this video, we're going to have a look at using Venn diagrams to calculate probabilities. So the question says the Venn diagram figure 1 shows the number of students in a class who read any of 3 popular magazines A, B and C. One of these students is selected at random. And part A asks us to show the probability that the student reads more than one magazine is a sixth. So let's try and show that. Let's look for all of the entries on the Venn diagram that correspond to the student reading more than one magazine. So this bit here, this is where the student reads both magazines B and C. And this bit here is where the student reads both magazines A and B. So these are the two combinations of events that lead to our final probability. So we're going to show it. We're going to exaggerate our working out. We know that the numerator is 2 plus 3. And the denominator is going to be the sum of all. So altogether, there's 10 plus 4 plus 2 plus 5 plus 3 plus 6 equals 5 out of 30, which is 1/6. So that's part A shown. Part B, let's delete those. Part B, find the probability that the student reads A or B or both. So A or B, so A is all of this, or B, all of this, and or both. Well, that's just that bit there. So, because there's not a question that says show that, the amount of working we do doesn't need to be exaggerated. So what we've got, find the probability that the student reads A or B or both. Well, let's total all the tops up. 4 plus 2 plus 5 plus 3 over, we'll work that out to be 30, equals 7/15. So 7/15 is the answer. Part C, write down the probability, let's delete those, write down the probability that she reads both A and C. Well, A and C don't overlap, so 0 is the answer. Right, part D, given that the student reads at least one of the magazines. Right, so we're looking only now at where the student reads one magazine at least. So the one that we don't count anymore, that's completely out of the question in this probability diagram, is that we've discounted that possibility altogether because we're given that they read at least one magazine. So find the probability that the student reads C. So we can see in C there that there's 9 altogether. So 9 out of, and let's total the rest of them up. 4 add 2 is 6, add 5 is 11, add 3 is 14, add 6 is 20. So it's 9 out of 20. We'll completely disregard anything else that isn't part of the situation described now because we're given that they read at least one magazine. Then finally part E, determine whether or not reading magazine B and reading magazine C are statistically independent. Well, statistically independent would be the probability of B intersection C equaling the probability of B times the probability of C. That's what statistically independent is defined to be. So the probability of B intersection C would be 3 out of 30. Which is 1 out of 10. Probability of B equals 10 out of 30 equals 1/3, and the probability of C is 9 out of 30, which is 3/10. So let's check that B intersection C, whether it's equal to probability of B times the probability of C. So probability of B times the probability of C equals 1/3 times 3/10 equals 1/10, which is equal to the probability of B intersection C. Therefore, B and C are statistically independent. And that's the question done. For more videos like this, go to alevelmathsrevision.com or subscribe to our YouTube channel. If you like this video, click the thumbs up at the bottom.